Alright, hello everyone. Welcome back. We're going to be doing linear relations again, 2 lessons here. They're a bit longer, so please pay attention. We're working on the outcome patterns, 8.1. Demonstrate understanding of linear relations concretely, pictorially, including graphs, physically, and symbolic. Okay, so the first part, identify the relationship in a table of values. So what a relationship is, is a pattern. Okay, a pattern formed by two sets of numbers. All right. So the pattern in this table of values describes a linear relation, and what a linear relation is basically a straight line. Okay, so it says graph the ordered pairs. So in class, what I would have done is probably played Battleship with you guys, but an ordered pair is basically two numbers that make a coordinate on a graph. Okay, here you have your x-axis, here you have your y. All right. So we have 0 and 0, good, 1 and 3, okay, then we go to 2 and 6, then we have 3 and 9, and finally we have 4 and 12, okay? So now what it says is plot the last three ordered pairs. So what you would do on your graph is you'd go to 2 and 6, you'd go to 2 on your x-axis right here, and 6, and you would make a dash, or a dot, okay? My stuff's not very neat right now because I'm doing it on a laptop. Alright, 3 and 9 is next. Okay, we're going to go to 3 here, we're going to go to 9, and we're going to plot our point. Finally, we're going to go to 4, and we're going to go to 12, and we're going to plot our point. As you can see, that is a linear relation graph. Okay, we have a straight line, alright, and it follows a pattern as we can see. Okay, what's the difference between consecutive A values? Alright, they do it kind of different here, and that's fine, alright? But what you can easily do is look at A and see how much does it go up by each time. It goes 0, 1, 2, and it goes plus 1 every single time. So you can go plus 1, plus 1, plus 1, alright? So here, what it does is it shows you the opposite. It goes 3 minus 2 is 1, okay? It takes the table of values here, 2 minus 1 is 1, and 1 minus 0 is 1. So it basically is just showing a difference of 1, okay? Now the difference in B, alright, as we can see, we go 0, 3, 6, 9, 12. Okay, well we're adding 3 each time, right? Here they do it different. They go 9 minus 6 is 3, 6 minus 3 is 3, and 3 minus 0 is 3. So our difference is 3, okay? Now it says, look at the graph. Describe how to move from 0 to 0 to the next, coordinate 0, 0 to the next point. Okay, well if I start at 0, okay, and I said, alright, we need to move up in this pattern, okay, how much did I move horizontally? Okay, well, you're going to look at your x-axis, okay, and you're going to see that horizontally is, you're going to look at your x-axis, yeah, and it's going to be 1, okay, we're moving 1 over every single time, and we're moving 3 units vertically. So if I went 0, and I went 1, okay, 1, 2, 3. And if I did it again, I'd go 1, 1, 2, 3. And I keep going up, okay, 3. So an expression, alright, basically what we're saying here, okay, is that you can write an expression like we did in the previous lesson to find out any value of the other axis. Okay, so let's say I know my pattern is going up by 1 and I want to know the 8th output of my table of values, okay. Well, what you need to know is that basically we had 0 and 0, okay, which never counts, but then we had 1 and 3, 2 and 6, 3 and 9, and so forth. Okay, well, if we look at the x-axis here and the y, okay, we take the x, alright, when we do these expressions, and we figure out if we took x for anything, what we could find the output. So here, okay, we do 1 times 3 equals 3, 2 times 3 equals 6, 3 times 3 equals 9. And we can see a pattern that we multiply the x by 3. So what it has here is 3 times a or 3a. Alright? So now if I said, alright, I want to find out the pattern of the 8th number of this pattern. Well, I'm going to go 8 times 3, okay, which is 3a in this case, alright, and I'm going to get 24. So the expression here is 3 times a or 3a. Okay, moving on. All right. The second part is determining if one is a linear relation or not by the table. Okay, so it says complete the chart to show the pattern and the values for each variable. So we have two tables here. Okay, we have table 1 and we have table 2. So the difference between consecutive first variables in the first table is 2. Okay, we go 2, 4, 6, 8. The second one, all right, we go 1, 2, 3, 4. So we're going up 1. Okay. The second one, it shows doing this way, alright, 7 minus 3 is 4, 11 minus 7 is 4, and 15 minus 11 is 4. As we can see, it's 4, okay? One other thing to note, okay, your pattern should be followed throughout if it is a linear relation, okay? And you'll see that very soon here. 4 minus 1 is 3, okay? 7 minus 4 is 3, 8 minus 7 is 1. Okay, so we went 1, 4, 7, which is up by 3, and then all of a sudden up by 1. Okay, note, that is very important. Now we're going to graph these. So we got 2 and 3 on the first one with 4 and 7 there. Sorry, that's not very good. 4 and 7 right there, let's see. 6 and 11. Right there. And 8 and 15. That's not very good. Anyways, when I make this, look at how straight it is. Okay, it is a linear relation. Alright? Now we're going to go to the second graph. We have 1 and 1. Okay, we have 2 and we have 4. Alright? We have 3 and we have 7. And right about there. And we have 4 and we have 8. Okay, sorry. So now, alright, if I was to graph this after, which is connecting the points, okay, I am getting a line that is not very straight, okay? And why do we think that is? The reason why is because all of a sudden we follow this pattern, okay, of going up by 3, alright, and then all of a sudden it just goes up by 1. So it just is not following a pattern, which means it's not going in a straight pattern of line. So table 1 shows a linear relation here. So it says, look at the graphs. Table 1 is a linear relation and table 2 is not. Explain how you know. Well, okay, if we look, the y coordinates are the same in our table 1 and not in our table 2. So, let's skip that. Just 1 second. Alright, so the last part here is use the table of values in solving a problem. So Sam is paid $7 for every hour of babysitting. The table of values shows how much she is paid for 1 hour, 2 hour, 3 hour babysitting. Okay, so what we want to do is look at this table. Okay, and we have 1 hour is $7. Okay, we have 2 hours is 14, we have 3 is 21, so 4, okay, what we're going to do is basically keep adding 7 to this. We have 28 and we have 35. So is this a linear relation? Explain how you know. Okay, well, I'm going to say yes right now, and we're going to explain how we know right now. Okay, so it says look at the table of values. Consecutive n values have a difference of, okay, n, we're looking at n, 1. Okay, or they increase by 1. Alright, p values have a difference of 7. And they increase by 7. This relation is linear because the number of hours changes by the same amount, and Sam's pay changes by the same amount. Let's say all of a sudden Sam gets overtime in her 6th hour, okay, and she gets $12 now. Well, this really messes up the pattern of the y coordinate, okay? So I'm going to show you how it shows the linear relation by graphing here. So we're going to go 1 and 7. Alright, boom. We're going to go 2 and 14. Good. 3 and 21. 4 and 28. Good. And 5 and 35. And if we graph this, boom, okay, it is a linear relation. Alright. One thing to note here that's very important is I didn't go over the graph very much. We've done that already. But what you want to do is have a title for your x-axis, title for your y, a label for your y and x-axis, numbers or units, okay, for your graph. So here the x-axis, it goes up by 1, okay, as you can see. So we're going to just go up by 1. Here, they made it very easy and they just went up by the values that you see, alright? So this one is maybe not the best graph, but I'd go up by 5s probably here. But you want to pick something where it's not going to show a large difference either. Okay, so the second part, write an expression here, alright? So look at the table of values to get from n to p multiplied by. So when we looked at our table of values, we had 1, we had 7, we had 2, we had 14, and so forth, okay? So to get n to p, what do? We multiply by 7, okay? When n increases by 1, p increases by 7. So there are 3 ways to write Sam's pay in terms of the numbers. The only ones I care about is the expressions, so it is 7n, okay? 7n. The reason why is because we can take 7, okay, which is our pattern here, and we can take n, which is our number of hours, alright, and we can find out any amount of pay for any amount of hours, right? So here, okay, how much will Sam be paid for 9 hours of babysitting? Alright, well, I can take 7 times n, or 7n, and I'm going to substitute n for 9. And I'm going to get 9 times 7 is 63. So she gets $63. I could do 10n, okay? 7, and then 10 as the brackets, and get $70. I could do 7 and 5, okay, as n, and I can get 35. So it's it's very easy to calculate the output when you know the pattern.